It is obvious to anyone that we exist, that we are here. But for us to be here, we must have come from somewhere. And we must be going somewhere as well. But where? Why? How and when? Well, tonight, we're joining the ranks of the philosophers, scientists, historians, and theologians, as science, history, logic, and reason are all brought to bear on this topic as we seek to wrestle with these questions, to get your questions answered, to discover the truth about human existence from the beginning of our world to our ultimate destiny. So our program for this afternoon is as follows. So there'll be about three 45-minute talks with breaks in between. After the second talk, there'll be complimentary refreshments in the foyer, and there'll also be time at the end of the last talk for any questions for any of the three knowledgeable speakers that we will be hearing this afternoon. Now, just to give a quick overview on how our talk titles relate to our theme, humanity's origin and purpose of existence. So where do we come from? Relates to humanity's origin. And we're going to answer that question. Why are we here? So that's the purpose of existence. But there's a third talk. Where's that title coming from? Well, what does the future hold? Well, if you look at the first letters of the title and scan your eyes down, it makes a neat acronym. H-O-P-E. Hope. That is the basis of what does the future hold. Well, we're really looking forward to sharing our presentations with you, and we're confident that you'll be encouraged and enthused by what you're about to hear. And without any further ado, I'd like to invite our first speaker, Mr. Matthew Crawley, to come forward and give the answer to the first question we have this afternoon. Where did we come from?
Well, thanks, Sam, and good afternoon, ladies and gentlemen. My name is Matt Crawley. I am the local representative of the three speakers here, an electrical engineer working in Blenheim. Now, before our next speakers discuss our purpose and our future, we must first determine humanity's origins. Now, there are really only a couple of options that we have to choose between. The first of these is that we are the result of chance. A happy coincidence of random events happening in such a way as to generate and form life. The second option is that our existence is not a result of chance, but instead a result of design. Someone or something must have created us and formed life as we know it. But before we get into the science and everything behind all these, we're going to consider the implications of these. Now, on your seats as you walked in, you would have noticed sheets of paper entitled references. As this is a very science-heavy talk, I have provided the references which I've used, and you'll notice as I go through little numbers popping up on the screen, so you can follow along and see exactly where my sources are from. And if you have any questions or you want to follow anything up, I would strongly recommend that you do that, so that you know that I'm not just making this stuff up. But anyway, the philosophy behind chance and design. If we are the result of coincidence and chance, then there is no reason or purpose for our existence. The whole universe is governed by just one law, the survival of the fittest. As the currently dominant species on Earth, humans, we get to enjoy free rein to do whatever we want, when we want. Long may it last. But there is a problem with this, because that means that morality, as we know it, is defined by the society in which we live. The populace decides what is right and what is wrong. At the moment, it says it's right to do what you like, but we have to make sure we don't hurt anyone else. But that's now. I mean, anarchy is just as politically correct in a time of anarchy as democracy is now. There is no outside influence deciding our fate. The future of our species and our planet is our responsibility and ours alone. This does mean there is no long-term stability, We are all at the whim of whoever happens to be the strongest and the fittest at the time. But there is good sides to this. We can do what we like, enjoy a clear conscience. The downside, there is no hope, there is no one in control, and reality strikes, we have no future as a species, particularly if we continue as we are. But then let's consider design. Well, what are the impacts of that? It logically follows if we have been designed, there must be a reason and a purpose for us being designed. You don't just make a cake for no reason. You make one to eat it. There is a purpose. The reason and the purpose will define morality for us. Whoever or whatever has made us will be deciding what is right and wrong. If we fulfill our purpose, then good. If we shirk our duty, then we should naturally expect some consequences. As our designer would presumably be the highest power in the universe, we are therefore at their whim and at their pleasure, their mercy, to dispose of at their whim and fancy. This is a problem. Humans like being top dog. We like doing what we want to do. There are restrictions on our behaviour, outside consequences for our actions. On the other hand, though, we do have a purpose, and that gives us a future, something that we can aim for, something to hold on to when life gets tough, gives us a foundation on which to build our way of life. So you can see by looking at the screen there that both chance and design, from a philosophy perspective, have both pros and cons. Being the dominant species on Earth and in the universe is very appealing, so we like that. We like being the result of chance. But when things get tough, we prefer there to be something else. There is a saying, there are no atheists on a sinking ship. When all other hope is gone, we all pray to something. So you can see also why some people would prefer to think we are the result of design. But what does science say? I mean, we live in the 21st century now. We have science. We have hundreds and hundreds of years of scientists telling us this, that, and everything else, and how everything works. So let's have a look, shall we, at what science says about where we came from. Firstly, it puts slightly longer names to chance and design and calls them creation and evolution. You know, scientists, they love their syllables. But we encounter a problem with these two very, very quickly. And it's to do with how science actually works. You may have heard of the scientist Karl Popper. There is a building named after him at the Canterbury University. He said that scientists begin by formulating hypotheses and then proceed to test them by observation. If the hypothesis turns out to be inadequate or wrong, scientists then formulate a new and improved one that can be again subjected to experimental tests. And you'll see there is little number 1 up there. That is the first reference that you'll see on your page. So the idea behind science is that if something can't be repeated in an experiment in a lab, then the theory is inadequate. It is not science. Your second reference is from the biochemist Dr. Duane Gish. And he says, and points this out, there were no human witnesses to the origin of the universe, the origin of life, or the origin of a single living thing. No one saw it. These were unique and unrepeatable events of the past that cannot be observed in nature or recapitulated in the laboratory. Thus, neither creation or evolution are actually scientific theories. They're both religious. Because science is observation, hypothesis, experiments, and more observation. The issue we have is that at the start of everything, nothing was observed. And it's impossible for us to create something from nothing. So the origin of life is not necessarily science. The other problem we face is that facts do not speak for themselves, they are read in the light of theory. That's a quote by paleontologist and biologist Stephen Gould. So whenever you are reading or listening to anything a scientist has ever said, when they start explaining why something is the case, we are leaving scientific territory and we're entering religious and theoretical. Because of this, you will find that there is a plethora of scientists who believe in evolution and a plethora of scientists who believe in creation, because neither is scientific, they are both religious. Some scientists, going through their data, will look at it and say, this supports my theory of evolution. Their neighbour will look at exactly the same data and say, this supports my theory of creation. So we are, as they say, in a bit of a pickle. But why is there even this debate? We've had hundreds of years of experiments. We should have a satisfactory answer by now, surely. And a serious contributor to this debate is the fundamental assumptions which have been made by both evolutionists and the creationists. Creationists assume everything was made in the form that we see it now. Evolution assumes everything was made purely by processes that we can see now. Neither of these things can be tested. You can't test the start of something from nothing. Here are some quotes from scientists discussing the difference between these two. They say the Genesis account of creation may even be the correct one, but there's no way science can prove or disprove it, and the creationists know that. Or we have the biology historian Peter Bowler. Miraculous creation is compatible with what we know. There is no way of disproving the claim that new species were created. On the other hand, there's no way of proving that miracles happened or that they can occur, because supernatural events of this kind do not appear to have taken place during the period of recorded history. I mean, you'd know about it. If all of a sudden a new species just popped up next to me here, like, wow, okay. That then proves that creation is a thing. But that never happens, it has never happened, and it never will happen. So we just have to go with other things. It's unprovable. We cannot prove it in this way. Well, what about evolution? Well, evolution is all about natural processes. So they say things like this: even if all the data points to an intelligent designer, such a hypothesis is excluded from science because it is not naturalistic. That was an evolutionist professor. Or we have the anthropologist Arthur Keith, who says, evolution is unproved and unprovable, but we believe it because the alternative, special creation, is unthinkable. Remember, creationists are everything was created as we see it now. Evolutionists are the processes that we see now formed everything. Both of those are not science, both of them are theory, both of them are religious. So we have two camps of scientists. Evolutionists, which admit their theory is unprovable, and creationists with a theory which you can't disprove. Both groups are adamant that the other group is wrong. So to solve this question of our origins for once and for all, we are going to come from an outside perspective and from the ground up, using purely facts that we can observe, try and either disprove evolution because it cannot be proved, or prove creation because it cannot be disproved. If we can do either of that, of those two things, then good, we have answered our question. So let's start our investigation. As all true scientists, let's start with some observations, shall we? Number one, we exist. There are some people who don't believe this, but I think most of us here would believe that we exist. Number two, everything we see has had a beginning. Thus we conclude humanity must have had a beginning as well. Number three, when two parents reproduce, the offspring looks slightly different from the parents. Thus there are changes that happen between the generations as we go through time. Number four, if you put creatures in a different environment, over time, they adapt to their new surroundings. We have more changes. The strongest, the fittest, and the most versatile of a generation will be more successful breeders, and more of their individual traits are passed down through the generations. It's survival of the fittest. If you are weak and sickly, then you will struggle to find a mate, you struggle to pass on your genes, and your traits are selected out. This is called natural selection. But once again, we see there are changes made as we move through the various generations. And lastly, we observe that the origins of things every day, baby humans trees, or capybaras, if you like, are derived from natural processes only. So let's start from an evolutionary perspective, and let's make the fundamental assumption that everything we see, the origin of life itself, must have come from natural processes only. Well, the current theory of evolution, which is prevalent today, says this. About 4.5 billion years ago, a chemical reaction took place in which the necessary proteins, catalysts, and energy came together in just the right way and formed a living organism, which looks a little bit like a blue bubble. This organism reproduced. Over a very long time and many generations, genetic mutations take place. Along with natural selection, this results in more complicated life forms, and over billions of years, these creatures split into the various families and species we recognize today, such as humans. Simply put, this theory says that the minor changes we see in day-to-day life in the different generations that you can see, if extrapolated over time, should account for the different species coming from one common ancestor. You know, you go back through your family tree, you'll see your granddad had a very large nose, you have a smaller nose. If you go back a very long time, does that mean he had no nose? Or a huge nose going back? We don't know, but it had to come from somewhere. You can see things changing over time. So how would we go about testing this theory scientifically, using facts? Well, firstly, if life forms have been evolving gradually over time, we should find, scattered throughout the fossil records, transitory creatures fossilized in the rock. So these are creatures which have a little bit of an arm here, a little bit of a leg there, and is not actually doing anything, but it's in the process of mutation. They're not functional, these bits and pieces which they have attached to them, but they're nearly functional. You would expect that naturally, wouldn't you, over time? If things are mutating, you can't expect an eye to all of a sudden just poof, appear in the next generation with all of the connections. It needs to happen bit by bit over time. So we should find fossil evidence for this. Secondly, genetic mutations in natural selection should be able to support the evolution of more complicated life forms from simple ones. More genetic information should be found in later generations than in the earlier ones. We should therefore expect to find an increase in genetic information as time progresses. And then lastly, it should actually even be scientifically possible for life to have originated spontaneously. We'll get there. Given the right conditions, there should be no such thing as a chicken or egg problem. When talking about simple life forms, you should have been able to come up with something which was not reliant on anything else. So that's the three tests that we're going to be looking at. Now, it would be nice if we could find such transitory creatures in the fossil record, but though we have been looking for hundreds of years, we haven't found any. I think, well, that's a surprise. Yes, well, you see, Charles Darwin had this a big problem. He said, innumerable transitional forms must have existed. Why do we not find them embedded in the crust of the earth? Why is not all nature in confusion instead of being, as we see them, well-defined species? You may say, well, that's ridiculous. I've read in the news recently they found some. It's like, yes, they've been finding them in the news for hundreds of years. But then also in the news, a few years later, they are no longer transitory fossils because they have discovered since then, using genetic information and just new information, that actually they're just complete extinct species. There is nothing that we have found which is half this, half that, or with bits that don't even work. So why is it that scientists, when they find these fossils, say, aha, we have found a half dinosaur, half bird? Well, it's because we aren't familiar with what extinct species look like. I mean, do you know what Archaeopteryx looks like? You know? Until we actually, you know what a monkey looks like. So if you saw a fossilized monkey, you'd be like, that's a monkey. But if you see a fossil you don't recognize, you have no idea what it is. It might be a weird-looking monkey. It might be a weird-looking bird. Who knows? So it's difficult to know what exactly it is. But because if you're an evolutionist, you see that, you assume it must be somewhere in between, because that's what you're expecting to find. Remember, facts are read in the light of theory. So science, time and time again, every time one of these things has been discovered, have said, oh, actually no, we were wrong with that one. Or they've found out it was a fraud, and people have just taken different bones, dipped them in different chemicals, and then said it was really old. But that's not all of them. Sometimes they have just made mistakes. So let's look at some of these transitory creatures, shall we? And we'll start with that one I mentioned before, Archaeopteryx. When Archaeopteryx was first discovered, it was touted as being a great example of a half dinosaur, half bird. It was fantastic. Everyone went nuts. But then they started doing different tests on it. They started examining the fossils with other fossils which they had found, the bits of the bone, everything else like that, and they discovered it's actually nothing like a bird at all. It's actually just a dinosaur. Paleontologist William Swinton said, that's the number 10 you see on the screen on that side, there is no fossil evidence of the stages through which the remarkable change from reptile to bird was achieved. And there are several others that we could look at. There are others where they have said, oh, this looks like a strange half dinosaur, half bird, and they found actually it's a bird. There was nothing reptilian about it whatsoever. Because when they are discovered, they didn't have access to the DNA testing, the genetic testing that we have. So they're just going by looks. But when you actually dig deep into things and you do look at them much more scientifically, you find actually they are just complete species. They are just weird-looking birds and dinosaurs. Another example we have is the Pakicetus. This was quite famous. It was half whale, half land animal, apparently. It had flippers that were actually half flippers and half arms. It had a tail, like a whale. But that's all they actually found of it. I'm not entirely sure how from the top half of a skull you can decide something had a tail. But anyway, they went with it. And then in 2001, they found the rest of the fossil. And unfortunately, it didn't have a tail, and it didn't have flippers. It just had legs. It's just another extinct land mammal. Or another example you may have heard of is the Rhodocetus. Similar thing again, half whale, half animal. Except now they say it was neither. It was something else. You find a discovery, you're not entirely sure what it is, you make your best bet. Later science then says, oh, no, we got that a little bit wrong. Now from an evolutionary point of view, that's not great. We would like there to be lots of these examples, but as Charles Darwin said, there just isn't. I mean, there are lots of other examples like this. You may remember Lucy when she first came out. They said, oh, this is half ape, half human. Not anymore. They're just an extinct species of ape. They're not related to humans at all. In fact, if you were to go through the references on the screen, you would find that actually the difference between Lucy and us is greater than the difference between us and other apes. So you have us, normal apes, and Lucy is way over here somewhere. So there's no way we could have come from her. So all we find from all of these fossil examples is not that there are transitory creatures, half this and half that, but instead we have just been killing a lot of animals over a very long period of time, and they're all going extinct. This is a quote from paleontologist Stephen Gould, who I mentioned before. The evolutionary trees that adorn our textbooks are based on inference, however reasonable, not the evidence of fossils. Or we have this one by the geologist David Kitts. Evolution requires intermediate forms between species, and paleontology, that's the study of fossils, does not provide them. The zoologist Mark Ridley says no real evolutionist, whether gradualist, i.e. an evolutionist who believes we have changed slowly over time, or a punctuationist, who basically believes that we're here and then all of a sudden we're now very different and then we're now very different again. But neither of them, if they're actually a scientist, use the fossil record as evidence in favour of the theory of evolution as opposed to special creation. So this doesn't say that evolution is wrong by any means, it's just saying there's no evidence in the fossils for evolution. But it gets worse. And this is where evolution starts getting into trouble, because fossils actually don't show things changing over time, they show things not changing over time. Have you heard of the coelacanth? It was found in 1839. It's not blue, but because my slide theme is blue, I have turned it blue. Apparently, it's been extinct for 65 million years. It's half fish, half mammal. You see the fins on the side, they're apparently very, very muscular, and they could potentially have been the precursor to legs, more so than other fish. This was amazing. Until they caught one in 1938, alive, and just swimming, using its fins as fins, not as legs. It was a bit unfortunate. What they found is that the extra muscles in the legs just help it stay in the same place when there are strong water currents trying to push it around. But it's not just this example. I mean, this was supposedly several hundred millions of years old. But the fossil from so many hundreds of millions of years ago is exactly the same as the living fish floating around now. So how does that work? How can something not change over such a period of time? It's not evolution, it's just lution. Then we have scorpions. So we've got fossils from 300 to 360 million years ago. One of them was huge, 70 centimetres, size of the scorpion. But apart from that, they are identical in every way to the scorpions we find now. Fortunately, those big ones are now extinct. In Utah, they found a fossil of a jellyfish from 500 million years ago. 500 million years ago. And it's exactly the same as jellyfish floating around now. So we have fish, we have scorpions, we have jellyfish, and there are loads of other examples that we could have talked about, but 3 is a good number, it's easier to remember. And they haven't evolved, they've stayed exactly the same. Things are not evolving over hundreds of millions of years. And you can't say, well, they must have just reached perfection. Okay, because the environment has changed so much. Creatures have to change to their environment if they are to survive. So there are just loads of questions which this brings up. Anyway, this just answers our first question. We're talking about evolution. Does it work? Our first test was, are there fossils found which are half this and half something else? No. Okay, that's a little bit of a setback, but maybe things, as we said, aren't taking a long time. Maybe they're just here, and then they have a really weird looking baby, and now they're here. And the mutation works really well. This baby succeeds and breeds, and it's fine. There is another theory. Okay, let's test that. Natural selection. Can mutations over time result in big significant changes? Test number 2. When talking about natural selection, we are talking about the passing on of certain genes which have been selected naturally. It's not rocket science, fortunately. And these then continue down throughout the generations. For example, blue eyes. Blue eyes were a mutation which happened in Europe a very long time ago. People found it attractive, and so there are now more babies born with blue eyes. And now we have loads of people with blue eyes. The question is whether these mutations over time, and we're talking mutations at a genetic level, can result in the evolution from one species to another. We know things can change colour, size, shape. We can see that. That is fact. That is science. What we are looking at is the theory as to whether, if we extrapolate over billions of years, whether we can get new species. I mean, where did nostril hair come from? Had to come from somewhere. One of the more well-known experiments carried out on this is the fruit fly radiation mutation experiment by a bloke called Hermann Josef Müller. He won a Nobel Prize for this work. What Herman discovered was if you put flies in an area with radiation, you significantly increase the rate of mutation. You also have the very short lifespan and insane reproduction rate of flies. He looked at thousands of generations over 50 years of fruit flies, looking at all of the mutations. This is the perfect evolutionary experiment. We actually have one scientist starting from the beginning all the way through thousands of generations looking at how things change over time. This is great. If our theory is correct, then these mutations over time should have produced a favourable result, and then another one and another one, passed down through the generations, eventually making a very different looking fruit fly, one more biologically advanced than its progenitors. So that's what we want, that's what we're looking for, because then we know we are a result of chance and we can do whatever we like. However, his experiment showed very different results. In more than 99% of the cases, he says, the mutation of the gene produces some kind of harmful effect, some disturbance of function. Most mutations are bad. In fact, good ones are so rare we can consider them all bad. So what the experiment showed is that over many, many generations, the mutations did not help the evolution of the species. It did not help them be stronger or more adaptable, but rather negative. They were getting weaker. If anything, this experiment shows that theory of evolution is backwards. We're actually devolving. And you may be thinking, yes, but you just said that they were blasted with radiation. I mean, hello, surprise. You blast anything with radiation, you're going to get sick. That's why you don't stick your head in a microwave. But it's not just creatures which have been hit by radiation. It's simple creatures, even just by themselves over generations. Bacteria, for example. Bacteria is very simple. It reproduces very, very quickly. It's another great experiment. You don't have to blast it or put it in the microwave, and you still get good tests. The geneticist Alex Mira, who did such a test like this, said this: one tendency in bacteria that seems to fly in the face of upward evolution, which would involve gain of new genes, is the tendency towards deletion of genes. Throughout time, information is lost, not gained. The reason for this is how natural selection works. The Japanese geneticist Mutu Kimura recognized that most mutations have an effect too small on a species over time for natural selection to pick them up. Natural selection can't see them. It's only the big mutations which have an impact on future generations. His findings are summarized in this thing called Kimura's box. So you can see on the screen there. Now, you have bad mutations on the left, good mutations on the right of that straight vertical line. And there you see there. Okay, so the mutation effect, positive mutation effect is good, negative mutation effect is bad. And you can see the frequency at which these mutations are happening as you go up. The higher up on the chart, the more frequently they're happening. Now, what natural selection looks for is for changes which are significantly good, so way over on this side of the screen, or ones that are really, really bad, way over on this side of the screen. I have one in front of me which is inverted. So if you have a really, really bad mutation, if you're way over here, hello, I got born with only one leg, then that is cold. That's not good for the future generations or the maintaining of a species. It's a bad mutation and it's significantly bad. And so natural selection over time gets rid of that. If you have really, really good ones, then natural selection sees that over generations. It's like, okay, that was a really, really good mutation. You are now far superior to everyone else. As a result, you're going to have more babies and your genes are going to get passed on more. But if you look at that chart, you'll notice there aren't very many very good ones. Because remember, as we said before, they're mostly all bad. And it's only significant bad ones which get noticed by natural selection. But as you'll notice there, most of the bad ones are inside what's called the no selection zone. And that's because natural selection can't see them. Over generations, it doesn't, you don't know that someone's been born with slightly worse vision. And they can still breed just as well as everyone else. But over time, these small genetic mutations, which are negative, and most of them are negative, are building up over time. If you want, there's a good reference there for that. The bad mutations slowly building up over time. That's not good. These not very big but bad mutations are building up throughout the generations. We're actually killing each other by breeding. And so is every other species in existence. There is loss of gene information as we go through. There's no gain. If there was, you would hope that there would be quite a few more good mutations on this side of your screen, but there's not. Experiment after experiment after experiment is showing that actually we're just slowly getting worse. Not hugely worse, fortunately. It's going to take a very long time before we're all dead, but it's getting slowly worse. Oh, goodness. So what we're seeing then is it's the opposite of evolution. We're not getting better, we're getting worse. It's devolution. That is what science is saying. So let's have a look. Our first test. Are there creatures which are half this and half that in fossils? No. Okay, well, let's adjust our theory and let's keep going because, you know, that's fine. We want evolution to be a thing, but it can't. We're not getting better over time, we're getting worse. And this is what science is saying. Our theory is flawed. That's not good. But let's just leave evolution to the side. What if we could just be generated by chance? What about the origin of life? Is it even possible for something to have come from nothing? So let's have a look at that then, shall we? Question number 3. Origin of life. Is it possible from nothing? Well, let's just think about what is required for a living creature to exist. It needs oxygen and water. Those are two fundamental things every living creature needs. It needs nutrients, an energy source, and some form of harvesting that source. Okay, that's quite a lot of stuff, but our theory of evolution is still happy. That's fine because we have had all of time, all of eternity, and possibly infinite universes for this to have happened. Ours just happens to be the lucky one. It's possible. You throw enough time at anything and it becomes possible. That's how maths works. But what happens if we look at the small scale? That's the big scale stuff. We just need oxygen. We need the sun to be a certain distance away from the earth. That's big scale, okay. But what about small scale? When we start looking even smaller than microscopes, this is when we need to start talking about DNA, the building block of life. DNA is what is called a polymer, which is a long molecule. There are two identical chains and each bit of DNA which twist around each other to form a double helix shape you can see there. So one of those strands is exactly the same as the other and they're joined together with bits. Now, to keep they are formed of 4 different molecules. Because they are virtually unpronounceable, they are instead called the letters of DNA. C, G, A, and T. So C is one molecule, G is another, etc. The order in which these molecules are connected to one another spell out different coding instructions for your body to read. Everything our body does, basically. And there are 3 billion of these in every single cell in the human body. The problem we face is that poor little DNA is very fragile. It is estimated that the DNA in an average cell in your body will break 1 million times every day. To stop it from completely just disintegrating, which would not be good for anyone, you do not want your DNA to disintegrate. We have these things in our body called enzymes which fix the problem. So DNA is reliant on enzymes. Every living thing has DNA, so the very first living thing had DNA. DNA needs enzymes for it to last much longer than a day. Well, the issue we have is that these enzymes are actually programmed into the DNA. DNA tells things how to make enzymes. So we start getting this chicken and an egg problem. So what came first? It's biologically and chemically impossible for either of these two things to exist without the other. The next problem we have is that DNA is code and can't be used without decoders. These decoders need energy provided by this stuff called ATP, which is generated by these amazing little biological motors called ATP synthesis motors. And these are amazing. They are incidentally way more efficient than any other motor we've ever been able to make. We're talking 99% efficiency or something like that. And it's not just humans or animals or complicated creatures which have all of these. Every single living thing we have ever found has ATP motors, it needs ADP, and it needs decoders, and it has DNA. Everything, from octopi to elephants to bacteria. But we have a slight issue because the instructions on how to make the decoders is contained in the DNA. And the instructions to make the motors is also included in the DNA. As Karl Popper said of DNA, the code cannot be translated except by using certain products of its translation. So which of these things came first? The ATP motor, the need for ATP, the decoder, DNA, or enzymes? They all rely on each other. Well, maybe DNA just formed by itself. Well, except it can't. There is no chemical reason for DNA to form. None. There is no reason why those molecules should form together. It makes no sense chemically. It's because DNA told it to. Instead of forming chemically, it needs these things called proteins to make DNA. But you need DNA to make proteins. So this is no longer a chicken and an egg problem, because that's only two things that rely on each other. We actually have heaps. All of these things rely on each other. There's no way that any of these things could have been by themselves. In the words of the science journalist John Horgan, there is a hitch. So what we find then is that DNA, the foundation block of all life, couldn't possibly have come into being by chance. There is no way that this could have come in by chance. You can't have enzymes without DNA. You can't have DNA without enzymes, or proteins, or ATP motors. You'll notice there are quite a few references there. I strongly encourage you to look them up if you are so inclined. But it's just amazing when you start looking at that. The only way that life, the first living thing, the origin of life, could have come into being was if something or someone created the ATP motors with their own copy of the DNA code, along with the proteins and the enzymes. Someone wrote the code for the DNA and put it implicitly in everything else. That's the only way that life could have started. And not just life. We're talking about everything else at the same time. Most people accept the theory of evolution because they think that most people accept the theory of evolution. It is a subject seldom discussed because it is assumed that the theory has been proved by science, irrespective of the total lack of evidence in favour of it. Remember our theory of evolution, things evolving over time from something which started from nothing? We've seen there are no examples of transitory fossils which actually stand up to in-depth analysis. You cannot gain new information over time, you can only ever lose it. And now we have discovered that you can't even start from nothing. Not by natural processes anyway. Paleontology, geology, chemistry, and biology say that evolution doesn't work. Evolution, ladies and gentlemen, is a myth and a fallacy. It is not supported by any science. This is what the Austrian mathematician, physicist, philosopher of science and metaphysician, I told you they like their syllables, said this: if by evolution we mean macroevolution, i.e. things changing species, it can be said with the uttermost rigour that the doctrine is totally without scientific sanction. Now, to be sure, given the multitude of extravagant claims about evolution promulgated by evolutionists with an air of scientific infallibility, this may indeed sound strange. And yet the fact remains that there exists to this day not one shred of evidence in support of the thesis that macrobiology transformations have ever occurred. So the only other option left to us then, unfortunately for those of us who like to do what we like to do, is that far from being a result of chance, humanity owes its origin to a designer. Now, although I'm very hesitant to use this term because there are lots of different ideas exactly what it means, because it's familiar to most people, let's just, for the rest of today, call this designer God. Please, though, remove any associations you have with this, any religious affiliations, whatever. We're looking at this purely scientifically. It's just a term we are familiar with to describe it, instead of always saying creator, because I don't like syllables. I like things to be nice and short because it's easy to remember. God is one syllable, so we'll use that. From our blank canvas that we've started with, all we have discovered so far is that we are the result of this God somehow. How exactly, we don't know. Who exactly he is, we don't know. What he's doing, we don't know. We then have to consider how exactly we got about being made. This is where an ancient book comes in useful called the Bible, which claims, I emphasize that again, it claims to be written somehow by this God. And the book starts by explaining how it reckons everything was made by God, by saying that it did get made by God. In the beginning, God created the heavens and the earth. But that's just the words written in this book. It's just an old book. Who can say whether this book is actually written by this God and can be trusted? Like, what if it's just a big scam or a conspiracy theory? If we're going to use this book to further explain our origins, our purpose of existence, and our hope, we then need to prove or disprove its claim to be written by this God. If we can prove it, then good. Using science, history, whatever. If we can prove it, we've firstly proved, A, that God exists because he obviously wrote this book. And then that also proves my subject, which was, where did we come from? It would prove that we are the result of creative design. But if we disprove it instead, and there is no evidence for a God, then both evolution and creation must be wrong and there must be something else. Maybe we are just a dream. We don't know. But examining the Bible's claim to be written by God is the job of our next speaker.